Assalamualaikum warahmatullahi wabarakatuh. I am Imazar Fabid Rihadinata from RAS1201C. Now we are going to represent the experiment 1, that is basic measurement. For the experiment, the objective are to determine volume and density of ball bearing, and the second objective is to determine the volume and density of glass block. The apparatus that we needed to do this experiment is vernier caliper, micrometer screw gauge, weighing scale, ball bearing, and glass block. As you can see in the diagram, there are vernier caliper and micrometer screw gauge. Procedure for the micrometer screw gauge is the mass of the hanger is measured and recorded. The weight of the hanger is calculated and the result is recorded as W in the table. The scale is adjusted so that the pointer on the hanger is positioned near the upper end of the scale when unloaded. Each position is recorded as 0. The hanger is loaded with a 10 gram mass and the scale reading is recorded. The load is incrementally increased by equal increments to obtain 8 data points before reaching the lower end of the scale. All data are recorded. The process is reversed by unloading. The same load as in the new scales reading are recorded for each load. The extension of the spring is calculated. The extension force act on the spring for each total load is determined. So the procedure for the vernier caliper is the whole number of small divisions on the fixed part of the caliper to the left of the O mark in the vernier is counted, providing the size of the object to the nearest whole millimeter. The first mark on the vernier that lines with a mark on the fixed part of the caliper is pound. The value on the vernier indicates fraction of a millimeter needed for a precise measurement. The zero error of the vernier caliper determined. The length, width, and thickness of the glass block are measured using the vernier caliper. Step 2 is repeated at least 3 times at different positions of the glass block. All data are recorded in a suitable table. The actual measurement of calculate, considering this earlier obtained 0 error. The weight of the glass block is determined. The density of the glass block is calculated.
Result for the experiment: to measure the length, width, and height of glass block using a vernier caliper and to determine its volume. The formula to calculate the value V is V equal to L times W times H. Zero error equal to 0. So for first attempt, we got length 10 cm, width 4.9 cm, and height 1.8 cm. For the second, we got 10.2 cm for the length. For width, we got 5.2 and height 1.9 cm. So for the third attempt, we got 10.3 length cm, 5.1 wide cm, and for height we got 1.9 cm. So for average length we got 10.2 cm. For wide we got 5.1 and height we got 1.9. So for true reading, first attempt we got 10 cm for length. For wide we got 4.9 and height we got 1.8. For the second, we got 10.2 for length, 5.2 wide cm, 1.9 for height cm. So for third attempt, we got 10.3 cm for length. For wide, we got 5.1 cm. For height, we got 1.9 cm. So for the length average, we got 10.2 cm. And for wide we got 5.1 cm and for height we got 1.9 cm. So all of this data we used to find the density of each item using this formula. So the formula is density equal to mass divided by volume. So for analysis, calculate the volume V and the uncertainties delta V of the ball bearing and the glass block. So we do volume equal to 4 divided by 3 pi R3. So we put radius in this data. So 4 divided 3 pi 12.975 power of 3. So the answer we got 9149.7812 mm power of 3. For uncertainty, we do 9149.7812 mm power of 3 divide 2, and we got 4574.89 mm power of 3. So for this, calculate the density P and the uncertainty delta P of the ball bearing and the glass block. For mass, 10.2 times 5.1 times 1.9. So we got 68.838 centimeter power of 3. For density, we use mass divide volume. So 98.838 centimeter power of 3 divide 3563.009 gram. So we got 0.02774 gram centimeter power of 3. So we got 2.8 times 10 power of negative 2 gram per centimeter power of 3. For uncertainty, we use the density divide 2. So 0.02774 gram per centimeter power of 3 divide 2, we got 0.01387 gram per centimeter power of 3. Last, we got 1.39 times 10 power of negative 2 gram centimeter power of 3.
And on the next slide, we can make a discussion about the experiment. In our basic measurement physics lab experiment, we aim to deepen our understanding of fundamental measurement principle, focusing on precision and accuracy in instrumentation. Our meticulous measurement of length, mass, and other parameters emphasize the importance of reliable tools like rulers, balance, and calipers. Deviation from expected value led us to consider systematic error or equipment limitations, providing insight into measurement uncertainties. Discussing the result, our emphasis on repeated measurement and averaging underscored the importance of consistency and offer valuable insight into the reliability of our data. Analysis of sources of error, such as zero error in instrument, allow for a comprehensive evaluation of our experimental outcomes. Additionally, the application of basic physics concepts showcase the integration of theory and practice in our lab work. The evident relationship between measurement and physical law reinforce the experimental foundation of physics. In conclusion, our basic measurement physics lab not only refine our practical skill in measurement, but also highlight the essential connection between accurate measurements
and the fundamental law of physics. The insight working contribute to a solid foundation for future experiments and scientific endeavor. Based on the experiment, I can make two conclusions based on the objective of this experiment. So the first conclusion is the experiment aimed to determine the volume and density of ball bearings through meticulous measurement and calculation. Valuable insight were gained. This exploration contributes to a deeper understanding of fundamental properties, paving way for enhanced application in various scientific and engineering domains. The second conclusion is the investigation sought to ascertain the volume and density of a glass block. Rigorous measurement and calculation were employed, shedding light on the fundamental characteristic of the material. This exploration expands our comprehension, offering valuable data for application in field ranging from physics to material science.
Assalamualaikum warahmatullahi wabarakatuh. My name is Imezafar bin Rihadinata from RAS1201C. Today I will present about Experiment 5, Hooke's Law. So the objective for the Experiment 5 is to verify the accuracy of Hooke's Law. So for the equipment that we needed to do this experiment is helical steel spring with supporting stand and scale, set of slotted weight hanger, and also weight balance. For unloaded spring, there are no amount of stretch, but for the loaded spring, there are amount of stretch. Because of the weight, they are stretching For the procedure, the mass of hanger is measured and recorded. The weight of the hanger is calculated and the result is recorded as W in the table. The scale is adjusted so that the pointer on the hanger is positioned near the upper end of the scale. When unloaded, its position is recorded as XO. The hanger is loaded with a 10-gram mass and the scale reading S1 is recorded. The load is incrementally increased by equal increments to obtain 8 data points before reaching the lower end of the scale. All data are recorded. The process is reversed by unloading the same load as in 3. New scale readings are recorded for each load. The extension of the spring is calculated. The extension force act on the spring for each total load is determined.
So result for this experiment 5. This is our table experimental data. So for load mass kilogram, we got 0.01, and total mass of load mass and hanger, we plus weight and hanger, so we got 0.02. And for weight of load mass and hanger Newton, we got 0.1962. Extension force F Newton, we got 0.1962. And for scale reading with load and for trial 1, we got 0.180. For trial 2, we got the same 0.180. So for the average, we got 0.1802. For extension of the spring, delta S equal to S1 minus with S0, we got 0.005. So for the next we use the same method. For the second load mass, we got 0.02. Total mass of load mass and hanger, we got 0.03. Weight of load mass and hanger, we got 0.2943. Same to extension force F Newton, we got 0.2943. For scale reading, trial 1, trial 2, we got 0.188. So for the average, we got 0.188. For extension of the spring, we got 0.013. So same goes to another. For analysis, you can see this is our graph. We plot a graph of the force causing the extension F against the extension S. So you can see this. So how much work done in stretching the spring through 0.20 m. So we find this. How much energy stored in the spring when it is extended to 0.20 m? We got 0.2943 Newton. For describe any error that may have occurred during this experiment, in the Hooke's Law experiment lab report, an error was noted in the calculation of applied force versus extension, resulting in inaccuracy in the determination of the spring constant. A procedural oversight in measuring the initial length of the spring before loading affected the precision of the results. This led to discrepancies in data interpretation, impacting the overall reliability of the finding on spring behavior. For what I can describe from our result about the relationship between the extension of a spring and the force causing, force is directly proportional to extension of the spring.
On the next slide, we have made a discussion about this experiment. In our Hooke's Law lab experiment, we gained valuable insight into the connection between force and deformation in elastic material. Applying different forces to spring and measurement resulting displacement consistently revealed a linear relationship, affirming Hooke's Law. Our result depicted in the force deformation graph indicate the material's adherence to Hooke's law within its elastic limit. Any departure from linearity could suggest plastic deformation or structural changes beyond the material elastic range, essential knowledge for practical application. Addressing anomalous or discrepancies in our experiment data, we considered factors such as friction, imperfect spring, or measurement error that might influence results. Mitigating these uncertainties enhance the reliability of our findings. Furthermore, recognizing Hooke's law application in the field like engineering and material science emphasize its significance. In conclusion, our experiment effectively validated Hooke's law within our experiment setup, showcasing a consistent linear relationship between force and deformation. Acknowledging limitation and sources of error contribution to our comprehensive understanding of the law application and importance in study material behavior. In this lab report, I can make one conclusion based on the objective of this experiment. In conclusion, the experiment aimed to verify the accuracy of Hooke's law. Through systematic testing and analysis, the result consistently aligned with the predicted linear relationship between force and deformation. This validation reinforced the reliability of Hooke's law, a foundational principle in the study of materials and elasticity. On the next slide, we have provide some references where we use it as our guideline. Thank you.